So welcome everybody on today's webinar. Some of you may already familiar with me, but some of you may not. I'm Miklos Szabó, working out from the Pattern Central European headquarters in Budapest, in Hungary. Today we're going to introduce you to a new high-capacity carrier-grade SBC, and I'm lined up with our co-host and guest speaker Kannan Nathasen, who is a head of product from Cataleya, which is a Singapore-based software house behind our new solution. But we will talk about this a little bit later on. Let's look into what we will discuss today. We will introduce you to a solution to a problem we like to address with the middle market service providers. You may ask the question, who are those middle market providers? They can be smaller tier 1 national carriers, ITSPs, large enterprises, UC providers, and even contact centers. And after that, we are going to talk about the brand new SmartNode 11K SBC in details. And with the help of Kannan, we are going to deep dive into the applications and use cases. And finally, once we finish the presentation, we will have some time to address questions. So please raise your hand in the Teams application or write your question in the chat. So as I hinted in the intro, we found a solution to the middle market problem. But what is exactly the problem of the middle market? The middle market operators have the issue because they are in the need of the same robust feature set from the SBCs as the huge big carriers with hundreds of thousands concurrent calls like AT&T, Verizon, Deutsche Telekom, etc. Their issue with the, let's say, big SBC vendors are costs. Those vendor costs doesn't really scale down very well to the smaller number of concurrent calls what they request. There are large service fees, support fees, annual maintenance fees, paid upgrades, hosting fees, bandwidth fees, etc. So let's look into it. How did we solve those issues? Our answer with the SN11K SBC solution to the problem was that we teamed up with Cataleya, who is a developer of a wonderful state-of-the-art, extremely featured software SBC solution. Solution is not too big, not too small, just about to seems to be right. It is well priced, not very expensive. It helps you dispensing the fee fatigue of the previously mentioned software costs. The Cataleya software is proven, reliable, feature-rich, robust, and efficient. With this solution, you can transform your voice network and cut your OPEX and CAPEX costs. It was designed exactly to the middle market, supporting up to 35,000 concurrent sessions. How do we position this new appliance? Let's look into this diagram quickly. Pattern is already well known for its small, medium enterprise SBC solutions. We call the SN1K series. Most of you are very familiar with this solution and using it in a large numbers, what we highly appreciate. Thank you for that. With these small, medium enterprise solutions, we can support up to 1,000 concurrent calls. But now, with this new appliance, we fulfill any kind of requirement with as low as 500 concurrent calls up to 35,000 concurrent calls. It is exactly the segment where the big SBC vendors with their huge solutions doesn't scale very well. With all the fees, what they are adding on the solution, like the previously mentioned annual fee, support fee, license fees, etc. Now that we have an idea where to put this appliance on the SBC map, let's look into the basic features. We hand-selected a carrier-grade server hardware. You may ask the question, why this is a big deal comparing with the commercially available commodity servers? Well, it is a big deal because, as you may know, the technology advances pretty rapidly. The components of the servers, like the processors, memory modules, motherboards, are becoming obsolete usually in a 2-3 years time frame. So if you are planning any kind of appliance based on them, you need to retest, rebuild, rescale the software and test the performance with every new hardware releases. Comparing with all of these, this hardware has a lifespan of 20 years. To serve the best scalability, it is coming with two different hardware options, a smaller one supporting up to 10,000 sessions, and the bigger one supporting up to 35,000 sessions and up to 3,000 concurrent core transcoding sessions. To ensure uptime, it includes a redundant, hot-swappable AC or DC power supply, can be deployed in high availability scenarios as 1+1 configuration. It is coming with a dedicated high availability interface towards to its peers, centralized management system for provisioning, element and service management, and the analytics is coming in either embedded to support lower number of concurrent cores in 1+1 scenario, or in a separate appliance in order to support higher number of concurrent cores. We packed the solution with bunch of new security features on various layers, network layer, signaling layer, session layer, and so on. And of course, to fulfill the modern needs, it is coming with the integrated fraud management, SLA monitoring, alerting, and very importantly with diameter signaling. Let's give a glimpse on the basic and standard software features. We do support all the traditional narrow and wideband codecs, including the new Chameleon type codecs like the Silk and Opus. As an interconnect SBC, it is coming with software-based transcoding, supporting peering protocols, full set of CPI, CPT, considering the CDR records, which are one of the most important data for a carrier, as basically their whole billing depends on its accuracy. The software offers a robust customization and formatting for those records. And of course, various levels of lawful interception is also supported. Security and privacy features include TLS, SRTP, malformed SIP message handling, and configurable access control lists. Coming with its own central management solution, which can be, as previously hinted, and either embedded for lower number of cores in a 1+1 configuration, as a separate hardware appliance for more than 10,000 concurrent cores options. It includes a user-friendly web-based analytics and reporting tool, code tracing, MOS scoring, and you can manage your configurations and software upgrades from here. And now let's go to the juicier stuff. As you may expected, similarly as the rest of the smaller Pattern SBC portfolio, this is also Microsoft Teams certified for direct routing. And also the Zoom phone certification is also on the way, even though if we already have some live installation for it. The diameter signaling protocol, which evolved from the radius protocol, is basically a typically big guy SBC feature. You won't see this feature on the entry-level enterprise SBC. SN11K SBC is designed to play a central role in web-based real-time communications to meet the today enterprise requirements, particularly for the contact center solutions, natively supporting CPREC, standard on session basis, and fight caller ID spoofing, prevents robocalls and call spams by using the stir-shaken standard. Now that we know about the core software features, let's skip the topic to the application and use cases. Thanks to the vast and various software features, the SBC can be used basically in all possible use cases and scenarios. It can act as a full-feature interconnect SBC, supporting transcoding, CPI, CPT, as I said before. Can act as an access SBC, offering business customer with hosted PBXs or collaboration suites, with the necessary tools for voice, video conferencing, and chat all under one platform. Or as you can see on the right-hand side, it can act as a full-fledged enterprise SBC with SIP connection to services like Microsoft Teams or Zoom. And now that we learned that this SBC essentially acts like a Swiss Army knife, I would like to give the word to Kanan from Cataleya, who will walk us through and let us deep dive into the application and use cases. Kanan, are you ready?
Thanks, Miklos, for that. I will be talking about some of the use cases. And before we dive into that, I'm pretty sure that you're thinking, why choose an appliance-based SBC where there are cloud-based SBCs or virtualized machines, etc. I would say that from a functional point of view, it doesn't make a difference, at least for this appliance, because all the modern features are also available in this. And whether you want to deploy this on an appliance or you want to deploy this on a virtual machine really depends on your IT optimization. But as far as modern features are concerned, we have you covered in this appliance SBC. Besides, this has predictable performance. Miklos was talking about selecting a specific hardware to do this. So we spent a lot of time ensuring that it can be optimized for consistent latency and reliability for the kind of capacity that we promise that it can handle. So you don't have to worry about whether this COTS server or the virtual machine actually meets your requirement. It simplifies deployment. We've had several instances where we procure or we helped our customers procure hardware where it came out in all kinds of dimensions, and we had to find out at the last moment that the model of NIC or the network interface card has dependencies or incompatibilities with the kind of software that we run and stuff like that. But having this in an appliance ensures that these risks are not there and you can easily deploy it. And finally, it's faster time to service. You can really plug and play. You can unbox, rack, and power on. Of course, it doesn't work right away. I mean, you have to provision it for some time to make it work, but then it is certainly easier than trying to install an OS, configure the virtualized machines or hypervisors, or do OS patching and stuff like that. What are some of the trends that are driving change in the SBC world, and what do these mean for modern SBCs? First thing is the blurring borders between hardware and IT. So we see even routers being implemented on merchant silicon. We have software-defined networks. We have a lot of advancement in the software area, and everything is come to be software today, which means that the SBCs must be operable by IT generalists and not just telecom experts. We did have a time where we had these monoliths of machines where we had one skilled person who was the only one who you would rely on to operate and manage. But this is now changing, and we have you covered on that side because this is a software, pretty much software SBC that actually runs on our selected hardware. And then there is data and analytics demands. We do have entire companies doing their business on third-party data analysis. So if you feed all this data to them, they can come up with a lot of these insights. Itself is a hub that actually controls a lot of data, both signaling and media. So you can get a lot of real-time insights that you can use for traffic optimization, quality control, and capacity planning, and more, in fact. And we have you covered on that aspect also with a lot of analytics and reporting. And finally, there is this rising UCaaS, CCaaS adoption. So everything is becoming as a service these days. And these modern applications require modern SBCs too that support different technologies, including Collaboration tools like Teams and Zoom Phone and WebRTC is also making a comeback with the contact center. And they also require agile SBC interoperability between the different components of this solution. So the pattern Catalia advantage is that patterns applying simplicity meets our software intelligence. So you'll see that you don't need specialized skills to manage and operate an SBC. So we had an epiphany moment with a customer. They said we don't want to have PhDs to operate and manage the SBCs. The SBC is a complex machine or a complex network element. Certainly, you would agree, but we've made it intuitive to use with GUI and API enhancements that you can actually build a layer on top of it with APIs if you want and integrate with your own OSS to simplify its operations. There's a lot of built-in analytics. So this is one of our strengths. So it has real-time dashboards for quality monitoring, traffic trends. There's a lot from service analytics and even troubleshooting tools from the SBC. And then you have scalability without re-architecting. So even though it's an appliance, any session scaling or feature addition can be done without any forklifting, as they say. Be it an addition of a feature or even be it that you have additional capacity required that requires more than one appliance to be deployed. We have you covered because the management element manager of the SBC product can manage multiple nodes in your network, be it in the same location where you deploy multiple appliances to ensure additional capacity, or if you want to do this in a geo-redundant mode, or you have multiple POPs, we have you covered on all that. And finally, there is carrier-grade reliability, and the SBC has been deployed with hundreds of carrier customers who demand the highest performance and reliability, and specifically also in high traffic environments like international gateways and wholesale voice. Let's get to some of the use cases. We just hand selected a few use cases just to show you that the SBC can be deployed in multiple segments of the network. And we've also taken, and when I talk about these specific use cases, I'm actually referring to particular customer case studies, of course, without any details. And that is why you may find that these are not typical use case diagrams, but it's kind of loaded, and you'll see what I mean. So overall, for the modern networks, there are deployments with Microsoft Teams and Zoom Phone peering. From ever since the pandemic, the popularity of these collaboration platforms have skyrocketed, and now there is a lot of adoption of these tools to be used as communication devices also. And this is why we certified with Microsoft Teams Direct Routing, and as Miklos put it, we are also undergoing a Zoom Phone certification. And then we see a lot of connectivity for CCAS and contact centers, or call centers, as they used to be called. And this requires seamless interoperability with existing contact center providers or vendors like Genesys, bring your own carrier, or with companies that we come to see as techcos today rather than telcos who want to sell a technology piece along with their connectivity services. And WebRTC is one of the things that has also made a comeback in these kind of deployments. And then you have the traditional access SBC, which protects your network perimeter. So this is the oldest use case of the SBC, where you have registration, caching, and optimization, and a security enforcement that is done on the perimeter of the network. And then, of course, there's enterprise SIP trunking generic use, which requires an interconnect SBC essentially, but which also can route intelligently to different termination partners. So the first use case is from the enterprise SIP trunking. So we did this for one of our customers in geo-redundant mode. So there were two SBCs that were deployed. And you can see that there are a variety of, let me use my laser pointer. You can see a variety of these customer side SIP trunks that are used. Of course, there is contact center connectivity also, and this is why this is not a typical use case, but more or less a depiction of what we implemented for someone. And we also had registered SIP trunks, static SIP trunks, and soft clients. And this PBX, we've come across a lot of these different models. I'll talk about this when we talk about migration itself. But essentially, what this means here is that the SBC must be flexible enough to actually talk to these different types of devices in the enterprise. This means header manipulation, an efficient use of that, and making sure that it interoperates with these different types of SIP flavors. And the geo-redundancy actually helps specifically where you don't want to have a single site failure to affect your services altogether. And the way we deployed this was in an active mode where both SBCs carry traffic, and from the endpoint side, we normally configure two different IP addresses, a primary and a secondary. So roughly about 50% of your registered or users or enterprises could actually come through SBC at site 1 as primary, and if that fails, it can go to site 2, and vice versa. This also presents a problem where when a particular site goes down, you have a flood of registrations coming from the other side to the available SBC, which results in what we call a registration avalanche that actually crashes different SBCs. So we have all these use cases covered, and these are general concerns of an enterprise SIP trunk provider. And we have these scenarios covered with efficient registration throttling on this side. On the core side, there's typically a class 5 platform. In this specific example, we use BroadSoft, but it could be really any class 5 solution that we need to integrate with. Specifically, since we brought up BroadSoft, we are not certified with BroadSoft, and we generally don't go the certification way unless we can absolutely not work in a scenario without certification. But we do interop with them whenever we get a chance. And this specific instance, we were able to complete all the interop cases with this BroadSoft element in 2 weeks. And again, this is mainly to highlight what we call a SIP adaptation framework feature in the SBC, which allows you to define very flexible and powerful header manipulation rules. And the next use case I want to talk about is a CCaaS provider. So this is a TechCo example that I was mentioning. So we have a lot of telcos these days that want to go up the value chain by developing a piece of technology and selling it alongside the connectivity services. So this is a one-stop shop for any contact center services from enterprises where it's completely centrally hosted solution, and it also provides the connectivity services and numbers. So here, this is a multi-node deployment where we had one SBC deployed as an interconnect SBC and two SBCs deployed as access SBCs. And the access SBC, and of course, the customer had a control app that or the contact center app that they had built in-house with the use of a class 5 switch. Perhaps they used free switch. They also provided a UCaaS service with a PBX, and in this specific case was 3CX that they were using. And the again, the trunk on the customer side, we support different types of connections. One being the web RTC client, which actually uses SIP over WebSockets to send communication to the SBC, which acts as a web RTC gateway, which converts it to SIP and RTP and sends it down to the network. Um, the specific customer in question also provides a programmable voice product, which is a CPaaS kind of product where applications can embed voice in their applications by using APIs. And it's just shown here, but it doesn't have any impact on the SBC except when the call is delivered. And of course, there were other types of connections like the soft phone client and static SIP trunk too. And in this specific case, there are scenarios which actually require the contact center provider or to actually use some of the SBC's additional services. One of the things that the contact center users were able to do with our APIs was to develop, we developed a composite service API, which we call Web Voice. And this contact center wanted the service specifically to deliver the one-time password through voice as part of a two-factor authentication. So apparently in some geographies, the SMS is not allowed and you have to make a voice call to deliver the OTP. And we were able to do with the service management framework for the contact center to develop a composite service API that takes a number and a message, and the service management kicked off a call to a text-to-speech engine. So we used Amazon Polly to convert the message to speech, and the service went on to place a call to the number given in the API and then play out the specific message. So just an example of what the SBCs can do or come in, to do more towards these contact center solutions, and we were able to do this for the contact center, and that's just to demonstrate the power of APIs. And then there's the typical Microsoft Teams use case. So this is the direct routing. So this could, we have a bunch of different customers, managed service providers, enterprise SIP trunking providers, even UCaaS providers. And typically we see this also where we have a mix of existing UCaaS and Microsoft Teams users. So it's typically a company that has a UCaaS subscription or a contract, but they want to try out Microsoft Teams for a single department. So this creates a unique scenario where you have both Microsoft Teams users and the UCaaS users. And typically, for these users, they have a PBX, and the PBX needs to send these calls to Microsoft Teams through the SBC. And this also needs the SBC to actually register to the PBX, because the PBX essentially has no routing capabilities. So the SBC registers on behalf of the Microsoft Teams users so that it gets all the calls that it can deliver to the Microsoft Teams. You can also see that these service providers can actually do an upselling of Microsoft Teams direct routing, apart from providing plain SIP trunking services, which is depicted by the lines here. And then a couple of large deployment use cases. We talk about wholesale, ICX, IGWs, and IMS here. International gateways is one of the straightforward cases. We have a lot of these deployments. So typically, you have international carriers sending in calls to the gateway, and the gateway distributing these calls to their own. I mean, so if this is this an incumbent carrier in a country who actually implements an international gateway, they receive the call, send it to their own domestic networks if the call is destined to their own network, or to the fixed and mobile networks within the country. And what we typically see here is implementation of mobile number portability lookup, which is also implemented as a service framework in the SBC, which helps you to look up a number portability server using any of the protocols supported by the MNP server. It could be SIP or enum or HTTP, and then route the call accordingly. And then this also has integrates with the BSS, which also has a little bit of least cost routing functions, which comes in handy when the call has to be routed to the least cost provider, or based on the type of services or products that the IGW offers to the carriers. And then we have the typical voice wholesale case, and this is a kind of a complex deployment that we did. But just wanted to highlight again, the kind of things that can be done with the SBC. So this is a global SBC deployment spanning across different locations, and each of these SBCs are connected with inter-machine trunks. So in this case, the customer used MPLS, but it could also be over public internet. Again, there are A to Z wholesale customers, calls being sent to suppliers, and there could also be all kinds of scenarios that are typical to wholesale, like bilaterals, origin-based routing, and many other things that are common to this particular use case. And we work with a lot of BSS vendors and LCR agents that take care of the least cost routing part. And typically, the SBC is able to relegate the least cost routing entirely to these, and we've have integrations with a wide range of BSS vendors that are popular today. And finally, we have the IMS deployment. So the SBC can work as a PCSCF in an IMS network. And of course, it can also work as a peering SBC, which is a typical SBC case itself. But the PCSCF actually has a bit more, because it needs to handle things like IMS AKA and conform to different standards. I'm actually showing you two different deployments here in the same diagram, where one use case is voice over LTE, the typical use case where a customer calls the network. The call comes into the IMS core through the access SBC or the PCSF. And we also have some border functions here, and also the access uh, uh, voice anchoring function. And the interconnect SBC. So the typical problems here are, or the feature requirements here are to ensure that it supports IPsec to the end customer, and things like IMS AKA conforming to different standards, maybe support diameter, and things like that. And the peering SBC is a typical interconnect SBC, but typically for IMS deployments, we see that there are uh, a lot of transcoding requirements, typically when the call is sent from one network to the other. On the right-hand side, this is a voice over Wi-Fi case, which is enabled by the element, the EPDG element. And once a call comes into the IMS core, it's similar to any typical IMS deployment. But this is typically how we've deployed both as peering SBCs and PCSCFs. And as you can see, the IBCF element ensures connectivity of the IMS network to another IMS network, as in this case, or to an MNO or to an NGN network. Yeah, I mean, we do have a lot more use cases to cover, but I think in the given short time, I hope I was able to give you a good idea of what the SBC use cases are and what is covered. I want to spend quickly, a couple of minutes on migration. I mean, the slide reads seamless migration, and I'm pretty sure you'd all agree that no migration is seamless. It is pretty ugly, but we actually want to make it seamless for the customer when they experience that. So um, we do have this experience of migrating from different SBCs, particularly in the cattle layer case. More than 90% of our 100 plus customers have been replacement of an existing SBC. So we have gone through this many times. We have experienced the pains, we have faltered, but we have learned from these lessons, and that is what we are hoping to deliver to you to ensure that with us, the migration is actually a controlled and predictable process and not a gamble anymore. So there's no leap of faith required. So some of the techniques that we have used or we have come to use is to see if the customer is amenable to a parallel deployment or a phased cutover. These are typically things that are done, nothing new in that. But what we also do is some amount of automation of configuration transfer. So since we have worked with different migration or conversion of configuration information from other SBCs, we do know what to do, and since we have APIs, we can automate this for bulk configuration so that this doesn't have to be painful. And then the most important thing being pre-testing. So if the customer wants to have a pre-staging environment, we always recommend that so that critical workloads can actually be tested out there. But more is done on static analysis. And in some of the customer cases that I showed you before, we really had a terrible experience because we had the particular enterprise service provider did not control the kind of customer premise equipments that the customers had. Like they had a variety of PBX brands. Each of these actually have their own idea of SIP. And when we did the cutover, we realized that we couldn't send calls. I mean, though the trunks were up and everything, the calls couldn't be delivered to a specific PBX. We had to do a rollback. I mean, these kind of scenarios are best addressed with a detailed static analysis. So we have this experience of failing, and I think nothing teaches better than failures. So static analysis, we've come to put a lot of importance on that. We dig as much information as possible in terms of traces, call flows, and we try to ensure that we have the right templates and the right policies set up so that it doesn't fail. And if possible, we also do pre-validation through a staging environment. So that's a wrap. Please come to us, talk to us for a personalized demo, see our SBC in action. We can talk about specific problems that you may have, and we can show you how it solves. We can kind of demonstrate that. You can also talk to our solution experts for a no strings attached free consultancy if you're considering an alternate solution, and if you have specific problems that you're not sure how it can be addressed by a new SBC. But if you really have made up your mind to move, or if you want to move ahead with us, we are happy to do all the technical deep dives and engage with your people to talk about migration or deployment strategies. Yeah, Miklos, over back to you.
Thank you, Kanan. It was great. So now that the presentation is over, we are coming to the Q&A session, and let me check for the questions. We have a few. So Kanan, if I read the questions, would you help us to answer them? So James is asking, I saw the T38 protocol listed on the slide. Will it also support the V.150?
No, because we don't see these devices, at least in our deployments. We've not seen this, but let me make a note of this also and check with the team. But offhand, we don't support that.
Right. Juan is asking if the LNP local number portability is supported, and if so, what methods are supported?
So number portability lookup is supported. What we typically do is query an external server, either with the use of SIP protocol, where we get a 3xx response and we act on that, or we can make an enum query, or if there is a HTTP protocol that is supported, we also do that. We do not have, we do have other mechanisms like, manually uploading these numbers onto some of our own data structures and doing a local number lookup, but this is not very efficient. But we may consider in the future to have some kind of local number cache on the SBC itself that we can look up. But today we do these external lookups.
Right. Gary is asking if we support the SIP method message.
We do support it in the sense that we don't act on it. So we suppose you want to use this for let's say I'm not sure if SMS over SIP. I mean, we can support these use cases as we just transparently pass it to the next element. So we don't block it, we don't process it. We can pass these through. So we can facilitate a downstream element actually work on that.
Right. One more last question is coming from Greg. If any intention to pursue DoD GTEC certification for the SN11K, I think this is something what Bert is already started to answer in the chat. So we are looking into it, and certainly this is something what we can look up for it, and yeah. All right, so let me check if there is any further question remained. I don't see any further questions. So just for the information, thank you for everybody for the active participation on the meeting. I appreciate it. And the recording will be available. So we recorded the webinar, and so we will make it somehow public, and we will send it over to you for so you can forward it to your colleagues, or you can revisit it if you have some interesting part of it. But once again, so thank you for joining today's webinar. If there would be any question regarding to commercials, please contact us on the sales@pattern.com. If there would be any technical question, you can also contact the support@pattern.com with your technical questions, and we try to address it over the email. All right, so probably that's all for today. Thank you for joining once again. Kanan, thank you for also for your participation, and
Thank you.
see each other next time. Thank you so much.
Thank you all.
Bye-bye.